Marcy and Spot teach you geometry. In this episode, we learn indirect proofs, vertical angles, and all that cool stuff. What's an indirect proof? It's where you prove that a statement is true by first assuming that its opposite is true. Let's try an example. Given angle 1 and angle 2 are complementary angles, we have to prove the measure of angle 2 equals 40 degrees. First, assume that the conclusion is false. We start off with the phrase, assume temporarily. So assume temporarily that the measure of angle 2 does not equal 40 degrees. Then, the sum of these two angles wouldn't equal 90 degrees. But this would contradict the given information that these two angles are complementary. So, the measure of angle 2 is 40 degrees. And speaking of angles, vertical angles, they're angles formed when two lines intersect. They are congruent, which means they have the same size, shape, and measure. This means the measure of angle 1 equals the measure of angle number 2. This also means the measure of angle 3 is equal to the measure of angle 4. So if this is a pair of vertical angles, and one of them equals 60 degrees, then the other has to equal 60 degrees too. What's an angle bisector? Is it a geometry student's nightmare, the meaning of life, or the rate that divides an angle into two congruent adjacent angles? If you picked A, you're wrong. If you picked C, you're right. An angle bisector cuts an angle in half. So if this angle equals 50 degrees, then an angle bisector will cut it into two congruent angles, where both would equal 25 degrees. So, perpendicular bisectors, what are those? Well, let's see. A perpendicular bisector is a line, a ray, or a segment that is perpendicular to a segment at its midpoint. M is the midpoint of segment AC. Line L is the perpendicular bisector. It intersects segment AC at its midpoint, also creating four right angles. All this talk of angles when we haven't even taught you triangles? Well, I guess we can start now. The figure formed by three segments joining three non-collinear points is called a triangle. Similar triangles have congruent angles and proportional sides. You can prove triangles are similar by proving that two angles of one triangle are congruent to two angles of the other. By showing that two angles are congruent and the sides including them are proportional, and showing that all corresponding sides are in proportion. But there's a special type of triangle, right triangle. They have one 90-degree angle. The short sides are called legs, and the long side is called the hypotenuse. So why does this matter? It's due to something called the Pythagorean Theorem. Let's call the legs A and B, and refer to the hypotenuse as C. The Pythagorean Theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. You can use the Pythagorean Theorem to help you find missing side measures. Use the equation a squared plus b squared equals c squared and then plug the numbers in. In this example, the hypotenuse equals 5. Wait, so no love for circles? This is like discrimination? Right. Well, maybe we could talk about circle areas and circumference. The circumference of a circle is almost like its perimeter, or the total distance around the circle. You find the circumference with the formula 2 pi r, with the measure of pi equaling about 3.14, and the radius equaling half the distance across the circle. Let's say the radius equals 6. Plug 6 into the equation, multiply 12 by 3.14, and get your circumference. The area of a circle, though, is the region inside the circle. It is shown by the formula pi r squared. Once again, pi stands for about 3.14, and r is the radius, or half the distance across the circle. Once again, let's say the radius equals 6. Plug 6 in for r. When you square it, you get 36. Multiply 36 by 3.14. This gives you the area of the circle. It's time for the question of the day, sent in by a person I don't know. What's the segment addition postulate? Let's check it out. The segment addition postulate states that if AC is a line segment and B is between points A and C, AB plus BC equals AC. We can use this postulate to find x. Just plug the numbers into the equation and use algebra to solve. In this problem, x equals 9. Last but not least, we have counterexamples. A counterexample is an example used to prove that an if-then statement is false. Find a counterexample to the statement if a squared equals 9, then a equals 3. Negative 3 is a counterexample. If a equals negative 3, then a squared is still 9. And this is how you use a counterexample to prove statements wrong. Well, that's it for now. Thank you very, very much for watching. See you later!